In the previous lesson, we chose the observation point and explained why the vector potential A appears in antenna theory. But A still needs a source description to work with. That source description is current density J. So this lesson asks a new question. If the observer is already chosen, how do we write the source in a clean mathematical form? Current density is not the same thing as total current. Total current tells us how much current crosses a surface. Current density tells us how that current is distributed over area and direction. This is the first important shift. We are no longer satisfied with saying current exists. We now want to say where it exists, how concentrated it is, and which way it points. Suppose the real source occupies a very small region in space. If that region is small enough compared with the geometry we care about, we often replace it with an ideal point source. This does not mean the source literally has zero size. It means we choose a cleaner model that keeps the source localized at one place while preserving the main physical effect. That is where the delta function enters the story. You should not read it as an ordinary pulse. You should read it as a localization tool. It tells us that the source bookkeeping is concentrated at one chosen position. So the delta is not visual decoration. It is the mathematical way of saying the source lives here. Now think about a thin dipole. Its current density cannot spread through all of free space. It must stay on the wire, and its direction must follow the antenna axis. This is why the dipole source model becomes a short, directed current element rather than a vague, glowing blob. The geometry of the wire now begins to control the source term directly. Once J is written clearly, the vector potential A finally has something concrete to integrate. That is the real payoff of this lesson. The source term is no longer mysterious. It carries a spatial story, a direction story, and a localization story. Because of that, later derivations start to feel motivated instead of arbitrary. So keep 4 ideas in your head. J is a source distribution, not just a total current. A point source is an ideal concentration of a small source region. The delta function is a localization tool. And for a dipole, the current density follows the wire and points along the antenna. That is the source model that prepares the next layer of antenna mathematics.